Good afternoon to you. Mark's out of HurricaneTrack.com here. It's Wednesday, the 4th of May, 2022, and today we're going to talk about wind, getting ready for the wind of a tropical storm or a hurricane. Obviously, that's what gets the big headline, 150 miles per hour, 80 miles per hour, something in between. The wind is usually what we think of when we think of hurricanes. We've seen a lot of video of trees blowing, especially in the deep tropics, those palm trees blowing in the wind with some spray or maybe some heavy rain accentuating that video to make it look really dramatic. We think of hurricanes, we typically think of wind. So my job today here is going to be to just make sure you understand the overall wind field of a tropical storm or a hurricane and the difference between a Category 1 hurricane and a Category 5. And I know you're thinking, well, come on, that's pretty obvious, but I have a great example to show you all in one video. We go from tropical storm to Cat 5 conditions all in one video. I'll show you that in just a moment. So let's get started, shall we? First, yes, this is where the scale that has existed for many decades, this is what I grew up with, the Saffir-Simpson Hurricane Wind Scale. Now, it used to be called the Saffir-Simpson Hurricane Damage Potential Scale, and there was pressure as part of it, and the storm surge was part of it. I don't think that Herb Saffir and Robert Simpson intended that to be the case. Maybe they did, maybe they didn't. But it is a wind scale, very useful for engineers especially. A pretty good little public tool, I guess, to give people a number, 1 through 5. 1 is the lowest category, and of course 5 being the strongest. You can get catastrophic wind damage, 157 miles per hour or higher. Category 1 hurricane, 74 miles per hour to 95 miles per hour. You're familiar, I think, enough with the Saffir-Simpson scale, but there it is. I'll put a link to this in the description of today's video for you. But by definition, a hurricane is 74 miles per hour or higher. Now, how does that ever get measured? How do they know? How does the National Hurricane Center know? Well, it's from satellites. That's the first detection. Air Force and NOAA, which is part of the Department of Commerce, they go out, so either military operations through the Air Force 53rd Weather Reserve Reconnaissance Unit, whatever it's called, the 53rd, and then the NOAA guys and gals, they go out and they fly and they measure in person using sophisticated techniques and dropsondes and all kinds of stuff. There's estimates through radar, where the radar beam can kind of get an idea of some of the velocities using Doppler shift. And then when these hurricanes and tropical storms hit land, they get measured by land-based sensors. The problem is none of the land-based sensors are calibrated the same. They're all different. The National Weather Service has their set at what are called the WFOs, the Weather Forecast Offices. We have private systems like what we own. We have university systems. We have private weather stations from Davis to, R.M. Young to Columbia Weather Systems. There's WeatherFlow, and probably a lot of other ones in between. You can pick these up at the mall. Do we still have malls? At Brookstone or something like that. You can order some of these online through some of these companies that I think some of you are familiar with these. Home weather stations, and these anemometers, those are the wind gauges. That's just a fancy word for wind gauge, anemometer. Those measure the wind speeds of our storms and hurricanes on land, but it's not a concentrated, quality-controlled effort by everybody. So you get these wild, crazy wind readings, especially in intense hurricanes like Ida, that run the gamut from nearly 200 plus miles per hour. We've seen some controversy about that down in Port Fourchon, to situations like what we ran into, where both of our anemometer systems, and we've got some really good equipment thanks to our crowdfunding, they blew off the bridges that we had them clamped on. Story for another day. If you haven't seen the video about that, it's on YouTube as well. And sometimes we get beat. So wind is hard to measure on land the stronger the hurricane gets. And so we don't have the greatest representation of what the wind speeds are in a hurricane, unfortunately. And it's constantly changing. All right? So let's just go back to the beginning real quick here. What is the basic driver of wind? Raise your hand if you know. It is pressure, the air pressure. The lower the air pressure, the higher the wind speeds usually are. And the reason is because you evacuate the air out of here, right? Like right here. You take the air out, air rushes in to replace that. That is wind. Low pressure in the northern hemisphere, of course, we have a counterclockwise flow spiraling in towards that low pressure area. And the lower the pressure is in the eye of the hurricane, the stronger the wind speeds are, usually in the eye wall, that donut of intense convection. But there's that word, convection. It is in the convection, or the thunderstorms, the updrafts, where you usually get these strongest winds. Usually. Not all the time, but usually. And the more defined a hurricane is on radar, when you can really see that eye wall, then you typically have stronger winds. So there's a lot involved with it, just like there was with storm surge. It seems easy enough, but once you start peeling back the layers, understanding the wind and preparing for the wind becomes complicated. It really does. So Saffir-Simpson scale is a good rule of thumb to understanding types of damage that you can expect due to hurricane winds. So if you're new to a coastal area watching this video, or you haven't reviewed the Saffir-Simpson scale in a while, here it is. Again, I'll put a link to it within the description of today's video, so you can take a look at that. All right? Where do you find the wind information within the public advisories? Well, here's Hurricane Michael from 2018. This is the day of landfall, October the 10th. We now know that Michael made it to Category 5 in post-analysis. I'll talk about what that means in just a moment. But at the time, 10 a.m. Central Time, 11 a.m. Eastern, on the 10th of October, Michael had maximum sustained winds of 145 miles per hour. Let's talk about that. What does that mean? That does not mean, let's first define what it doesn't mean. When you hear on the radio, NOAA weather radio, in a television broadcast, whatever, somebody's reading it to you, you read it yourself, maximum sustained winds are 145 miles per hour. That does not mean that the entire hurricane has 145 mile per hour winds. It does mean that somewhere within that circulation, probably the eye wall, recon in this situation, more than likely it's recon that is close to landfall, measured in some specific spot a wind speed averaging about 145 miles per hour for 1 minute. But even that is, I don't want to say complete malarkey, because they don't have a tower sitting out there in one spot. They drop these dropsons, they drift, they get blown around. It's 1 minute. It's a 1 minute average. The plane is flying at 300 knots or so through that eye wall, and it's recording its instrumentation, picking up the wind speeds. It's all done with math. The flight meteorologists, they're the ones that figure all of this out. But it is still an estimate, because the dropson that they fire out the back looks like a little toilet paper tube or paper towel tube with a parachute on it, a little bit bigger than toilet paper tube. That thing gets pushed out the back and it blows all around. Sometimes in an intense hurricane, it can end up in an entirely different quadrant. The plane is moving. They're measuring air wind speeds based on the movement of the plane and how hard they're getting buffeted. It's all complicated, but I'm telling you, these are estimates still. It's their best guess based on the data. And then there's other methods. They use step frequency microwave radiometers, which is a microwave way of looking at the surface of the ocean to see how fast some of the wind streaks are going, but that is subject to maybe if the water is too shallow. This gets complicated. But the bottom line, when you see it in the public advisory, maximum sustained winds, 145 miles per hour, that doesn't mean it is everywhere. And they usually mention, especially in the discussion, where the winds were sampled. So that's where you get the maximum sustained winds. That's the 1 minute average. And then just a little bit further down in the public advisory, hazards affecting land. In this case, storm surge was the big issue. But then there's wind. And they talk about, in this section right here, the different wind radii, how far out from the center tropical storm force winds and hurricane force winds extend out from the center. They discuss that in the public advisory. So let's see if I can find it. Wind, probably, let's see if they mention it in here. I know that they do. There it is, right there. So data from NOAA and Air Force Reserve Hurricane Hunter aircraft indicate that maximum sustained winds are near 145 miles per hour. And then right here, that's the paragraph I'm looking for. Hurricane force winds extend outward up to 45 miles from the center. So that is very, very important to know. So amongst all of this that I'm throwing at you, the one thing that I want you to remember the most is to understand how far out from the eye hurricane force and tropical storm force winds extend. It's baked into the public advisory, and it's in the section here, discussion and outlook. That is the section. So they do a brief discussion right here, and in this area, they say hurricane force winds extend out to 45 miles per hour from the center. Tropical storm force winds extend outward up to 175. Tropical storm force, that is 39 miles per hour to 73 miles per hour. So if you want to know about the wind radii, how far out from the center those winds extend, and even this is not a perfect circle, depending on the shape and the structure of the system, the wind might be confined to a certain quadrant. It might be stronger in one quadrant than another, but this is where you find that information. In the public advisory, in the discussion and outlook section, read it, when there's something coming, and understand from that what the extent of hurricane force and tropical storm force winds are. All right, now here's another little clue for you. Typically, we see a hurricane once the air pressure, you see how here down here it says minimum air pressure was 928. Well, that was a formidable strengthening up to Cat 5, Michael was. But usually when we see the air pressure around 987, 985, somewhere around there, usually that's the first sign that you've got a hurricane. So sometimes the air pressure has to lower and then the wind speed catches up, especially if it's deepening or strengthening very quickly. Other times you can have a pretty windy hurricane with a higher pressure. You get, you think Barry 2019, some of these marginal situations. And the reason is there's a lot of recon getting flown into these, and so very little is getting by the forecasters. It could be a hurricane even just for a brief moment. So public advisory, very, very important tool for you to understand when a hurricane is coming, what the deal is with the wind speeds. All right? Now, here's a great example. This is Laura going back to 2020. That is the look of an eye wall that just screams well-developed, yikes, look out. Like, that is what you look for when you say, where's the core? Where are those really nasty winds going to be? So, Laura had winds of 150 miles per hour at the time of landfall. Those 150 mile per hour winds were not up here, and they were not over here. They were measured somewhere in this eye wall. Exactly where, I couldn't tell you. It might be within this little area right here where you got some high reflectivity on the radar indicating hail, grapple, probably. Very intense updrafts in the hurricane eye wall. That's a probable spot where there could be 150. Is it going to be over here? Probably not. We can look at radar and generally get an idea now of where the strong winds are likely to be. Now, this is just the base reflectivity. There's a lot of different layers of radar, and this is radar scope that I use and a lot of our team members use. And I don't have time to get in that. I don't want to do a radar scope tutorial, but just eyeballing the base reflectivity here, and we've gotten good at this ourselves. You can say, okay, in this band, yeah, that's going to have some strong winds coming with it. And the tornado warning was up. There was embedded tornadoes within the wind field. And we're going to talk about tornadoes here in a couple of days as a separate entity, a separate hazard. But it's this core down here. That is where, more than likely, your maximum sustained winds are going to happen. The core of the hurricane around this area right here. So when this moves over your location, wherever that may be, that's bad news. It's also bad over here. You can certainly get 90, 100 mile per hour wind, but that worst of it is in the core, especially of a very well-developed hurricane. Now let's juxtapose that, contrast it to this. Okay, this is Delta. All right, several weeks later, but this is Delta. And Delta was not looking quite as impressive, right? You can see it's got an eye wall, but it's missing those deep reds. It doesn't have that sharp, like, oh my goodness. It's still nasty looking, right? I do believe this is Delta. I mean, yes, it is. So just understanding what we're looking at via radar and the differences here, you can see this was a weaker, less defined hurricane, but the worst of the winds are typically going to be in here. Delta had a lot of rain out in front of it. That's a whole other process going on there. But that's the difference. And of course, tropical storms are going to look less organized than this, and so forth and so on. So radar reflectivity satellite presentation really helps us to understand the structure. And like I said, typically these nasty winds right here, like they talk about with Michael, for example, 145 miles per hour, that's going to happen within that core more often than not. So here's another example. This is how we measure the wind. We use these anemometers. That's the wind gauge of choice for most research-based organizations. We use 4 of these. We have 4 of these in our employ, as they say. It's hard, though. They get knocked over. Debris hits them. You've got gremlins constantly, electronic gremlins, as they say, trying to screw things up. Measuring the wind speeds of a hurricane is very, very difficult. It's very challenging work. There are a lot of efforts out there to deploy towers. University of Florida, the Coastal Monitoring Program. Texas Tech has these wonderful 2-meter like tripods. It's called the StickNet program to gather information 2 meters, 5 meters, in some cases 10 meters, 15 meters up in the air, open exposure of what the wind speeds are doing in tropical storms and especially hurricanes. So that's what our wind gauge looks like, one of several. And we can mount these to bridges, either strapping them down or clamping them down or both. Just depends on the situation. What does that look like? What's the data look like? Well, here it is. This is that exact spot. This is what we got. This is Laura. And all of these reds are your hurricane force gusts, and the blues were the 1-minute averages. So we have a lot of observations. You can see it's turbulent. You get these periods. Let's use a color that pops a little bit better, Mark. You get these valleys in here. You see these lulls. These are when the bands come and go. And then you get these periods of increased activity. A couple of spikes there, and then right as the eye wall was coming in, this was on the west side of Laura's core. By the way, just to show you where this was in relation to everything, once Laura made landfall, the weather station that you're seeing there was sitting right over here on the west side of Laura's core, just outside the worst of the wind field. I wish we'd had something on the right side, but you can't. It's almost impossible down there in southern Louisiana. Story for another day. Be sure to watch the Laura episode of our Hurricane Highway series. It's almost ready. It's 2 parts. It's so long, I broke it up into 2 parts, but you'll see how hard it is to measure the wind speeds. But I digress. So that's what our data looks like right there. A lot of effort to gather wind speed information for the public, for engineers. There are people, for example, like the great Tim Marshall, who has an engineering and a meteorological background. And he goes out and he looks at structures after they're hit by tornadoes or these severe hurricanes, and he can tell you the telltale signs of how a hurricane did what it did. Because the biggest thing are these gusts. The wind is coming along and it's just blowing and blowing, and then you get these big stabs. And if you've been in these hurricanes, you know what I'm talking about. And it's those unpredictable 1, 3, 5-second gusts, however long they last, usually not much longer than that, because it's terrifying, especially in these intense hurricanes. Those do the damage, those big monster gusts, downbursts, the vertical transport of energy. The rainfall helps to drag that wind energy down. A very convectively active hurricane that's got that sharp eye wall, that's typically going to bring those winds down to the surface a lot more easily than a hurricane that isn't quite as reflective on radar. Remember I showed you the pictures there, the two different pictures, the radar images, contrasting Laura with a sharp eye wall right there versus Delta. See, huge difference, very noticeable difference there. This is not going to transfer the wind to the surface as easily as what Laura did as an example. So, all right, what else? Showed you this. How about some resources for you? International Institute, well, not International, slow down, Sudduth. Insurance Institute for Business and Home Safety. I knew the acronym much easier. I thought I did. Insurance Institute, IBHS. It's two I's, though. I confuse myself sometimes. Anyway, let's put the link up for you right there. See, it is IBHS.org. I'm reading it over here on the logo, and there's two I's, Insurance Institute. Anyway, this is a great resource, even if I can't pronounce it, for understanding how, preventing avoidable loss, just like it says, pathways to preventing avoidable loss through mitigation measures. So I'm going to put a link to this for you in the description. Plus, and I do know how to say this, the Federal Alliance for Safe Homes Flash. That one's easier. Another great resource, and I'll put a link to these. Check it out, especially if you're concerned about wind damage, and not just from the wind actually hitting your home, knocking your windows out, that kind of thing, but think about falling trees, airborne debris, that kind of thing, hurricane force wind, tropical storm force wind. The wind is the wind. It just depends on your local area. What can happen? Fences get knocked over. Your kids' toys, lawn furniture, you name it, gets blown around. It's a very complicated setup once you think about your own personal situation, your business, your home, your car, keeping your car safe. There's a lot involved here. So the point that we're trying to make is just to raise awareness. Yes, hurricanes are pretty much known for their wind, and let's just be ready for it. And what are we getting ready for? Say get ready for it. Well, let's look at an example here. Like I said, pretty much all of the categories wrapped up into one. Again, I showed you this yesterday, this extraordinary example of Hurricane Michael. Remember, it made landfall Mexico Beach back on October 10th. The pressure was 919 millibars officially at landfall. So we set that camera up, and while we are setting it up, the wind was, 25, 30, 35 miles per hour. It comes and goes with the bands. Again, this is about 2 hours before landfall. We set it up, and you can just clearly see in this video here, it's a windy day, kind of gusty out there, sheets of the wind driven. There's a good gust right there. There's a gust. That's what a gust looks like. And it's manageable. A couple of signs are going to blow over, some vegetative damage. No real big problem. But 11 o'clock, it starts to pick up just a little bit here. This is just a phenomenal example all the way through. And we'll stop right as the storm surge comes in, because that's a whole different animal. And we covered that yesterday. But you're going to see what I talked about in what I've just said to you in this video. So, it's just kind of windy in the background there. You see some siding that's gotten blown off. There's one of those stabs right there. See, a building that's behind the camera is starting to get some damage there. It was a property called the Forgotten Coast Realty. Their building was behind the camera. This is a GoPro. There's one of them. Look at that. Look at that downburst and how random it is. It's not just a straight line gust. There's a straight line gust. That's horizontal, but the other one was vertical. That is amazing, and there's no way to predict how that's going to play out. There's just not. Now, at this point, the core is getting closer, and we start to do some serious damage. That's toucans there in the background. We're getting some really strong ground level wind. And by 11:56 a.m., the roof comes off toucans. The wind is just screaming down at the lowest 10 meters of the atmosphere, 30 feet down to ground level. Even in the distance, looking up Highway 98, pieces of roof are coming off all the way back up the road there. And there's not even any sign of storm surge yet. Seriously, this is a great example of the hurricane ramping up. Tropical storm force when we set it up. Now we're in hurricane conditions, estimating, I would think the wind speeds here are 80, 90, 100 miles per hour, maybe higher. And they come and go. As you can clearly see, you get these bouts of extreme wind. There's a lot of damage starting to happen here. The eye wall, that core of well-developed Hurricane Michael coming in to the shot here, almost whiteout conditions. In fact, I do believe in this video I enhance it so that we can see better. I can't remember if I do or not on this one. Yes, I do, right here. So we're going to switch it over now. It's going to be enhanced. It's just a little bit. I took some of the whiteout conditions out of the video so you enhance the darker colors better. Surge is starting to come in just a little bit. Now we're in that core of a violent Category 5 hurricane. Look at all the windborne debris. That's the eye wall. That's what it looks like. That's what you don't want to be unprepared for wind-wise, wherever you may be. And if you're right at the coast like Mexico Beach is, there's just not much you can do. Look at all of that. Let's just freeze it. You can see in the shots, pieces of who knows what. There's a piece there in the middle, and all of that is flying by at over 100 miles per hour. That'll knock your windows out and cause a lot of problems there. So a great example, Hurricane Michael, of what Category 5 wind can do. We'll go back over here to the Saffir-Simpson scale. Catastrophic damage will occur, and that is exactly what happened there in Michael. And then it had the storm surge to go along with it, coming in just as the core came in. So there was a double punch there in Mexico Beach from Michael. All right, so again, before I get out of here and post this for you, the links to the IBHS and the flash site, Saffir-Simpson scale, I'll put all that in the description of today's video. We're on Twitter, on Facebook, and on YouTube. Those are the three main social media outlets that we take advantage of. And we, of course, are supported through our crowdfunding efforts at Patreon. Go to patreon.com/HurricaneTrack or get the app, or just aim your smartphone at the QR code if you want to become involved with our community and fund what we do, but also to be a part of it. It's not just, a funding site. We're actually all work together and, get on board and you'll see what I'm talking about. And when we do our live coverage, there's just nothing else like it. That Michael video I just showed you, yes, we streamed that live from the live cam as it happened. But you probably already know that by now. That's what we are so much known for, is the field work. But before we get out to the field work, we got to get you ready, get your mind in the game, understanding all these different hazards. We've covered two of them out of that acronym. Remember, SWIFT. Yes, the Saffir-Simpson scale is helpful, but that's for wind. The SWIFT method here: surge, wind, inland flooding, and that's going to be tomorrow's topic. And then we'll wrap things up on Friday talking about tornadoes, which is going to be hard because I've never actually observed a tornado myself in a hurricane. I've seen them out on the Great Plains a few times, but we'll figure out what we can do to educate you about that. All right? As always, thank you for tuning in. At the very least, hopefully I motivated you to learn more about preparing for the wind and how it can affect your house, your business, your automobile, your pets, all of that. The wind, that gets the headline. Be ready for it. All right? All right, I am Mark Sudduth, HurricaneTrack.com. Thanks again for tuning in. I'll be back with more for you tomorrow.